Yeah. Slideshow. Is it you? Yeah. It should be you. You're sharing the slides, so. Page. Stop sharing. So you can put it on the slides. So how do I? I don't know. Is that good? Sure. Yeah. Yes. I mean, crazy. One you sent us, we have to observe it, or we have okay. If it doesn't work, now you have it, yeah. So there it is. It's a little better than taking it. Yeah. He wants to do that. Yes. We need to talk about this. I did my research. All right. Good. Okay. Yep. Okay, that's good. It's okay. Next time, one more. That can lead that on. One more, two more. One more. That's it. Right there. All right. Yeah. Thank you for your help. That was a good exercise. I should put the microphone on and keep the sound. Oh. Tomorrow morning, I need to come and come to the when I need to come for the day, I got it out. Yep. You guys hear me okay? Yeah. Thank you.
All right. Okay. First, we say sorry for starting late because we have some technical problems. Internet. We're about to start today. We've got another speaker from Freeport. We could remember a few weeks ago, the president was here, and then he told us that you're going to be here, and you're going to tell us some technical part of Freeport. So today we might hear them from you. So our speaker is Bowsher, who is the managing life cycle decarbonization and sustainable mining at Freeport. And he has been leading the copper miner for more than 2 decades. And he is the manager in that department. Jason holds the BS Bachelor of Science in Mining Engineering and Masters in Business Administration from University of Arizona. He currently heads the life cycle and decarbonization team within Freeport Sustainable Mining Group, collaborating with both internal and external stakeholders in the capital efficiency optimization of key equipment assets while delivering projects that will enable the international mining company to efficiently achieve its pathways. Ladies and gentlemen, let's put our hands together for Jason Bowsher.
All right. Well, thank you, everyone. So as he mentioned, I'm with Freeport, and what I'm going to talk about today is decarbonization pathways. So this is really going to focus on more of the scope 1 emissions that we're trying to abate. But hopefully this ties in quite well with some of your interests. One of the things I wanted to do, if I could, is I wanted to thank you all for this opportunity. I've actually never been to CSM before. I've heard a lot about it growing up, but my grandfather actually graduated from CSM going back to 1934 when he got his BS degree, and he followed that up in 1940. So anyhow, there's always been a connection to CSM. Never been here before, but I came over a little early today and walked around campus. Really nice campus, a lot of history. So I wanted to make a point of sharing with all of you. I might be a graduate of the University of Arizona, but there's a piece of CSM in my heart. Okay, I keep going to the wrong screen there. So I'm going to do a little bit of a level set today. So, when I first got into mining out of school, I remember within the first day being on the job, there was an engineer surveyor that walked me around, kind of helped me get acclimated and orientated. And he's like, okay, Jason, you've had 4 years going to school, but there's only a few things you need to know, right? And he shared this with me and I've never forgotten, right? But in mining, we measure with the micrometer, we mark with the crayon, we cut with the chainsaw. And it's very true, but it's really interesting because looking back on it, some of it, him sharing that with me was a little bit of his frustration, right? We go out in the field, there's such precision in what we do. And then you turn around and you see this huge shovel just basically plowing through, and there's really not a whole lot of precision to that. So you kind of fast forward to where we're at today. I think it's important to highlight that mining is actually coming from a position of strength today. We've come a long way, right? Our mines are safer, more productive, more cost efficient. When you think about the relationship with the workforce, we have as good of a relationship with the workforce that we ever have before. The level of engagement, collaboration is at its highest level that we've seen. So certainly for us as Freeport, we lean a lot on our workforce to help us solve some of the issues and the challenges that we have. And so moving on, again, when you think about technology, right, you've heard the old adage around work smarter, not harder. But there's a lot of technology that we deploy in the field. And so when you think about decarbonization going forward, we're going to be relying pretty heavily on technology. If you look in this right-hand corner here, right, you go back over time in mining, right? Back in the day, there was a lot of focus on production. It's like produce, right? They started getting more focused on cost, being profitable. And then there's this recognition, right, that, hey, we're hurting people. And you saw this transition where safety became more and more important. And then along the way, even environmental stewardship.
So now when you think about these key priorities of safety, environmental, cost, production, now we're layering in this whole decarbonization, and I'll get into some of that detail with all of you. So the group that I work in within Freeport is called Sustainable Mining. So we've all heard the word sustainable. It has a lot of meanings. Certainly for us, it's beyond even just decarbonization. Sustainability is, for us, it's how do we sustain our mine plan? How do we sustain our assets? How do we sustain the workforce, right? And so it's really, really key to our business, and certainly for other companies as well. But I wanted to highlight here, when you think about sustainability, this is our Miami mine. Back in 1993, we purchased this 4100 shovel. It went through a life cycle. We rebuilt it, redeployed it to our Morenci mine. And so it's been operating at Morenci, and then here in late 2023, we actually rebuilt it again. So we have a shovel that's on its third life, basically running 250,000 hours. So rather than replace the assets, we actually have a pretty good program where we actually rebuild those assets to basically brand new. But we've done a lot of activities since 2006. This is a key part of our business. It's part of our cost profile. Again, rather than spend $30 million on a brand new shovel, you can rebuild it for half the price. It actually operates and is reliable, just as good as new. And so it's no different. We've had haul trucks that started at Morenci. They went to Grasberg in Indonesia, and those same trucks actually are being deployed at our Cerro Verde mine in Peru. So again, just another element of when you think about sustainable mining. And at the same time, we're also making new investments. So this is actually our latest addition, a brand new 4100 XPC AC shovel to the Morenci mine. So it's not all about rebuilding assets. We're also bringing in new assets as well. So has everybody heard a little bit about greenhouse gas reduction, scope 1, scope 2, scope 3? Anybody? Okay. So what I'm going to talk about is primarily right here in the middle today. This is what we call scope 1, right? And scope 1 are the emissions that come directly from the site, from the equipment that you deploy, the fleets that you manage. That's really tied in with scope 1, and I'm going to focus on that. But you also have what they call scope 2, and scope 2 is you bring in electricity into the operation. You got to run your mills. You got to run other facilities. Where does that electricity come from? Is it renewable? Is it non-renewable? And so non-renewable electricity, of course, can create greenhouse gas emissions. So it's no different than the diesel consumption is producing greenhouse gas emissions. You can have non-renewable coming from coal, gas, right? An example of renewable would be solar, windmills, etc. This one over here, the scope 3 is actually more on the supply chain side, and it's further down the road, and that's actually something the industry is pulling together as we speak. But wanted to give you some context on what scope 1, 2, and 3 is, but I'm going to focus on the one here in the middle. So for Freeport, we've actually have set some targets. And one of the things I wanted to go over this is how we measure our greenhouse gas reduction is in terms of copper intensity. Okay, and so copper intensity is a measurement of how many metric tons of CO2 you're producing. Divide that by how many metric tons, in our case, copper that we're producing. So basically for every metric ton of copper, how much CO2 are we creating? And so this is referred to as copper intensity. And so getting back to the scope 1 and scope 2 emissions, right? That previous slide, that's where you're impacting your numerator here. And then obviously we're trying to produce the product copper. So what we've done as a company, by the end of this decade, 2030, we actually plan on reducing our greenhouse gas emissions by 15%. And if you look at Freeport, Indonesia, they actually have a separate target of 30%. But by 2050, as a company, we plan to be net zero on our greenhouse gas emissions. And so we call that an aspirational goal. And the reason why that's aspirational is a lot of the technologies don't yet exist. And if they do exist, they're not yet scaled for our application. Right, as you guys know, we use a lot of energy in mining. So again, this is based on the 2018 baseline. So if you look at this for the Americas, right, our copper intensity was 3.72 back in 2018. So we're shooting to have that at or below this by 2030. So we're looking at 3.17 more or less. Okay, so when you think about decarbonization challenges, it's really across the board. It can't be emphasized enough. Decarbonization is the right thing to do. We're very focused on it. It's a commitment, it's a goal, but there is no such thing as a free lunch, right? So when you think about decarbonization, you're taking the existing model and you're basically turning it upside down. So when you think about safety, right? The safety that we have today, unfortunately, as people say, a lot of the rules, regulations, best practices have all been written in blood. Along the way, people have gotten hurt. We've had fatalities. You go back and you look at what went wrong. How can we change things? How can we improve? And so we've gone through those iterations. And so we're pretty dialed in on our safety right now. So when you think about even decarbonization, you're introducing new technologies. What are some of those challenges with those technologies? What are the risks associated with that? And so this is going to be really key for us because we don't want to hurt anybody. When you think about the workforce, today we're struggling to hire electricians, mechanics, welders, operators, even engineers. And so to think going forward that that's going to improve, it's not going to improve. Right, so we've got to be very proactive on the workforce. The supply chain is already constrained, right? And so now you start thinking about all the materials needed for this transition. There's really not enough materials out there, quite frankly. And we're not the only ones that struggle with workforce, right? Every industry out there is struggling with the workforce. When you think about mine planning, right? We have all these existing operations. They've all been designed with shovels and trucks, right? The pits are very mature, they're very deep. You can't just go in and just change the pit around, right? It's been designed a certain way over the life of that mine. And so what adjustments or enhancements can you make to those existing operations? But that creates a challenge. Mine equipment is difficult to retrofit, right? Today we're running diesel, mechanical drive trucks, right? Well, if we're going to transition to decarbonization and eventually net zero, I got to get away from that diesel engine or that diesel fuel. So am I able to take my existing assets and retrofit those assets with a different power module? A lot of this, again, does not exist. And then lastly, it's capital intensive. And I'll give you guys kind of like a reference point. A standard haul truck today runs you about $5 million. And based on preliminary projections working with the OEMs, they're putting a 2x multiple on that. So a $5 million Cat 793 truck today is going to become a $10 million truck in the future. Right? So when I showed you this previous slide, our business model today is all about taking these existing assets and we keep rebuilding them. So a $5 million truck brand new, I run about 500 of them. I'm going to rebuild them for 2.5 million. 2.5 million. Cycle after cycle after cycle. Well, if I can't retrofit those trucks, in the future, those 500 trucks need to be converted to the next generation haulage truck. So take 500 trucks times $10 million. Just haulage alone, that's a $5 billion investment just in the haul trucks alone. That doesn't include all the enabling technology that goes with it. So this is part of what I'm sharing, is that it's highly disruptive. Again, it's the right thing to do, but it's highly disruptive, right? And so when you think about just general business, you're sustaining the business, you have to reinvest in the business, right? There's a lot of work that goes into tailings dam management. There's a lot of work that goes into As pits get deeper, more mature, those ore bodies get mined out, you have to invest in new projects. So everybody's competing for this capital. And so now with this decarbonization, we have this new competitor for capital. So another area I want to highlight, this is part of the challenges. So when you think about copper, of course, copper is really important to us. That's our primary focus. And we're excited about the green transition. I mean, copper is going to benefit immensely from this transition. But when you think about where we stand today, and this is actually, these figures are based on an IEA study from back in 2021. But we're roughly at 25 million metric tons of copper production per year today. And so the projection, and again, this is independent, by the year 2035, you're going to need double the copper production that's being produced today. And if you look at this chart that I threw in the middle, this is actually showing you the existing operating projects right here in this shaded area. And so what this is showing is this is the projection over time. And as it currently stands, you don't have copper projects that are going to be able to actually supply the world with the copper that's projected to be required. And so this is going to pose some really big challenges for society as a whole, but certainly as a mine operator. We're trying to spend money reinvesting in a new fleet of haul trucks that are zero emission, but at the same time, I'm competing because I also need to reinvest in expanding my existing operations, exploration, developing new projects. So there's a lot going on. And so it's not just a Freeport issue, it's actually an industry-wide issue. And I'm talking about copper here, but copper is no different than all the other commodities out there. This is also really important. So this is also from the same study. And, you know, there's some different key minerals here that are on this chart, but, you know, highlighting copper. In this study, if you look at from 2010 to 19, the average project that came online, it was over 16 years. And so when you think about this big transition that we're in and the world needs all this copper, part of the challenge we have is the permitting, right? It's one thing to go out and explore, find the ore bodies, be able to have the resources in place, develop those resources, but you can't really do anything until you get those permits. And so if I go back to the previous slide, and we're saying today, roughly in 2020, and by 2035, we're going to double, that's 15 years. So the average project, according to this IEA study, over 16 years. So you can see where there's a lot of challenges. And I think that's worth noting. And again, it's not just about copper, but just think about the demand now that there is on lithium and nickel and cobalt. The list goes on. Okay, so I'll start getting into a little bit more detail now. So the question is, what are we trying to solve? So for Freeport, right, we're a shovel and truck company, right? Open pit, primarily open pit mining. And so you look at this graphic here, and this is showing the mining cycle. You have a truck that's loaded at the shovel, right? It's got to run to the stockpile or the crusher, right? And it just repeats, right? And so what we're trying to do now is, if I have a net zero truck and I'm not using diesel, okay, I'm going to be loaded at the shovel. Well, that's where you hear a lot about battery. If I have a battery that can allow that truck to operate, that's what we want to do, right? It's around the battery propulsion. And then you hear a lot more about trolley assist. So how can I propel the machine while at the same time recharging that battery? And then there's times when I'm not exposed to dynamic energy transfer, which is what trolley is. And now I'm back to using my battery again. Cases where you have a downhill haul, like today's trucks, there's all this regenerative energy, and they end up blowing that energy off, right? They dissipate it from the truck. So now it's like, well, maybe we can take that energy and put it back into the battery. So really what we're trying to solve is, how do I take an existing haul truck today that I'm basically just running these cycles, right? The mining cycle. And now I don't have diesel, but I got to keep those trucks running. And so that's when you think about these enabling technologies. The technologies of the battery, technologies of the dynamic energy transfer, right? Leveraging regenerative opportunities. So I think this is really important here on the bottom. So you can see this is a 793 Caterpillar haul truck, right? A 240-ton payload. This is the diesel tank right here. So if you go to this other side of the chart, that's that same diesel tank relative to a person. And what we're talking about is we roughly need 40 megawatts of stored energy. So today I can take a haul truck and run that truck basically 24 hours on a single fuel tank. We only refill our trucks once a day, and it's a 15-minute refuel. So this small little tank that's got well over 1,000 gallons, around 1,000 gallons of diesel, can propel this truck to work in this cycle in a 24-hour period without a refuel. If I actually have a battery on this truck that's equivalent to today's model, this is how big that battery needs to be relative to the size of that truck. I'm not going to be hauling any material with that truck. I'm going to be hauling this battery, right? So you can see what the challenge is. So these are obviously the different chemistries. You got your lithium titanium oxide, you got your lithium iron phosphate, nickel manganese, cobalt. So this is the difficult part, because realistically, you can't have this size battery on a truck. So beyond batteries, we're also looking at hydrogen. There's liquid hydrogen, and there's hydrogen in its gas form. But this is part of what we're trying to solve. So it's very complex. If I could highlight on this, I know it's kind of small, but what this is showing here in the black, this is actually out of all the greenhouse gas emissions under scope 1. This is haulage in the black. Okay, so you have support equipment in the green, you have drills. We run diesel drills, blast hole drills. That's 5%. Support equipment is 15%. You have another bucket, but roughly haulage accounts for 75 to 80% of your total diesel consumption. So when you hear a lot in the industry about, well, why is everybody focused so much on haulage, battery electric trucks, hydrogen powered trucks, is because if you want to make the most impact on decarbonization, you got to go after your haulage fleets. At least for us, that's the biggest culprit. And so that kind of explains. So again, this is what we're trying to solve. Here's today's model, overlaid with some technology. How do I make this work? How can I keep a truck running like it is today? Because if a truck is not going to run efficient like it is today, instead of having a fleet of 50 trucks, do I need to now have a fleet of 60 trucks or 65 trucks in order to make the same production? So it's really important. So like this slide here, we've gone through a lot of stuff internally. This is actually looking at alternative energy sources. This is like a trade-off study that we've done. So this is looking at biodiesel, renewable diesel, compressed natural gas, liquid natural gas. You have trolley assist. There's battery hydrogen cell, and there's hydrogen combustion. So you go through these different areas like, okay, will these actually lower my scope 1 emissions? Yep, they all will lower your scope 1 emissions. Certainly there's some zero emission solutions over here. Availability at scale. So a haul truck, if you want to run a haul truck today for a 24-hour period, you need 1,000 kilograms of hydrogen. So if I have a fleet of 50 trucks, I need 50,000 kilograms of hydrogen per day to run a fleet of 50 trucks at a mine. I have 500 trucks. Where am I going to get 500,000 kilograms of hydrogen? It doesn't exist. And we're just Freeport. Throw in the Newmonts, right? Throw in the BHPs, the Rios, FMGs. So the supply is not there. So you can kind of go down here. There's obviously cost impacts. Again, mechanical drive. Those components are not configurable to actually running trolley assist, battery, and hydrogen fuel cell. So yeah, so these are just some of the exercises that we've gone through as a company. Because one of the things I will say is, like, every company is a little different, but one of the first things you need to do is really understand what's your profile. So this is touching into a little bit of thermodynamics. If you guys haven't touched up on your thermodynamics, probably not a bad idea. But this gives you an idea, right? So let's just take battery electric, direct charging. You're basically wire to wire. You run through that 100% renewable electricity that goes in. And by the time you go through those conversions, your efficiency is 73%. And this can fluctuate, right? Just think in terms of order of magnitude. And then you think about hydrogen, you're going from wire to gas, back to wire. So that same 100% renewable electricity, when you go through all the conversion, you have the losses across, you're only actually 22% efficient. And depending on how you produce your hydrogen, right, a common way is actually through electrolysis, right? So we operate in the southwestern US, water is kind of scarce. We're going to set up hydrogen production plants. Where are we going to get the water? And on top of that, I need all this energy, and I need a lot of it, because at the end, I'm only going to get 22% efficiency out of producing that. So part of this is explaining the complexities of kind of what's going on and what we're trying to solve, and how do we get there. But you know, laws of thermodynamics don't lie. They are what they are. And so we'll see how that progresses going forward. So one of the things to share about this, right, is yeah, we're trying to maintain parity of where we're at today. But at the end of the day, it comes down to the feasibility. So when you think about TCO, right, total cost of ownership, it might be that my capital costs actually double and they go much higher, but the goal is, can my operating costs go much lower, right? If you have renewable electricity, if you're running at 4 cents a kilowatt hour, you know, there's actually some opportunities to bring your operating costs down, even though your capital is going up. So at the end of the day, when it's all said and done, it's really ultimately about how feasible is it, right? How much am I investing? How much am I putting in? What am I getting out? So this is very similar to the previous matrix I shared with you. Again, as a company, you look at your profile and you try to understand, okay, where do all these technologies fit? And what does that mean in terms of a TCO, right? The cost impact. Okay. So I've kind of talked about this, you know, current mine profile versus future mine profile. You know, there's definitely a really good exercise around strengths and weaknesses. I mentioned earlier, we're a shovel and truck company. So our mindset, like my training in mine engineering has been around shovels and trucks. I'm very comfortable with shovels and trucks. But that may not be the solution in the future. Okay. So when you think about a weakness for Freeport, we got a bunch of mine engineers that are all truck and shovel guys. And the reality is we got to actually shift away from that. You hear the references around, you know, trying to put a square peg in a circular hole, right? Or vice versa. It's not a one size fits all, right? There's not going to be any kind of silver bullet. A lot of what we talk about in our business is beware of the shiny objects. You know, when we started down this path a couple of years ago, you had like a channel of solutions about this wide. And everybody had all these great ideas. Well, 2 years later, a lot of those ideas have kind of fallen off because they just, for whatever reason, weren't feasible or the timing's not there. But that channel's gotten a lot smaller. But it's really easy when you get these channels of all these ideas to get distracted. And so that's kind of what we mean about avoiding the shiny objects. No question, you know, you guys think about, you know, outside of engineering, think about organizational readiness, you know, having commitment from your leadership, top down. How do you get employees involved? How do you get them to buy into the process? really good partnerships with Caterpillar, with Komatsu, developing new ones. You know, and I like to mention too, right? It's really around embracing the growth process. You don't know what you don't know. And I've lived by this for a long time now, but you got to be comfortable being uncomfortable. Like I said, some technology exists today, but it hasn't been configured for the industry that we're in, right? It's one thing to put a battery in a regular automobile, given the size of that battery, the fact that you use that vehicle a couple hours a day, 4 hours a day, 8 hours a day on a road trip. But we're talking about a haul truck that's consuming over 1,000 gallons of diesel in a day. And you're trying to keep that asset moving at all times, right? So again, a lot of that stuff just doesn't exist yet today, but I'm confident that we'll get there. So this is a little bit about our strategy as it relates to scope 1. So I talked about leveraging the OEM. So we have a really good partnership with Caterpillar, with Komatsu, with others, ABB, even Liebherr, a lot of new players. But we're trying to leverage the portfolio. So these are actually the 4 pillars that we're focused on. We're going to try to be as efficient as we possibly can with our assets. Control what you can control, right? So we have a lot of work that we've done around analytics. There's even an operator scorecard. We're very good about managing truck idle time. We actually are in the process of deploying autonomous haulage at our Baghdad operation, which I have a slide on that here in a little bit, but you'll have somebody giving a talk, I think, in another month, Randall. He's actually going to go into in-depth on autonomous, so you guys can learn more about autonomous haulage. And we've actually been evaluating ultra-class trucks, and there's actually an operational efficiency with that. Looking at these different alternative fuels, you think about biodiesel, renewable diesel, even LNG, CNG, you can actually use existing assets for those alternative fuels. It doesn't get you to zero, but certainly it could be a bridging strategy to get us to where we need to be in 2030. And one thing that's really important is this alternatives to haulage. So I mentioned about this mindset that we have around where shovels and trucks. Well, thinking outside the box, what if you move away from shovels and trucks? Or maybe let's say we move away from trucks because our shovels actually run on electricity. But if you had a way of leveraging conveyor belt systems, so if you take a conveyor belt system and you can put a renewable electricity in that conveyor belt system and figure out a way to get that material into the conveyor belt and have that material move to where you need it to go, whether it's the crusher or to a stockpile, you actually can remove haulage altogether. So again, it's not a one size fits all, but let's say I have a fleet of 50 trucks today, and I figure out a mine design where I can put an in-pit crusher and a conveyor belt system coming out of the pit. What if it shaves off 15 trucks? So instead of running a fleet of 50, I'm running a fleet of 35 trucks. That's actually an effective way of moving towards decarbonizing your mine. So we're actually spending a lot of time right now on alternatives to haulage. Looking at the preliminary models, I mentioned, a brand new haul truck is going to be twice as expensive. The operating costs actually don't look like they're competitive either. So that's actually driving us to actually look at alternatives to haulage. The problem that we have is we have a couple operations that move 900,000 tons a day. So when you think about a conveyor belt system moving 900,000 tons a day, it's actually very, very complex. So we're studying that. And then of course, I've been talking about the electrification side with battery. So this whole strategy that we have is really looking at today's model, knowing where we want to be in the future at zero, but what can I do from where I'm at today to get me to that future state, right? So I'll throw out an example. If I take existing assets, so I can lower my capital, right? I'm not having to go out and buy brand new trucks. If I go out and actually can convert over to renewable diesel, right? So maybe I pay $3 a gallon today for regular diesel. Maybe I pay $4 a gallon for renewable, so my costs are going to go up. But renewable diesel, you have an opportunity up to almost, call it 99% to remove the carbon. It's not a long-term solution, But if we're waiting on Caterpillar and Komatsu and other industry partners to develop the technology, there's things that we can do in the interim. And that's really what this is when you think about in terms of a bridging strategy. Okay, so there's really three fundamental questions here, right? These first two I have up on the top. What can we do now? I've been talking a lot about how do we leverage existing assets, right? So right now we're running Cat 240 truck, 240-ton trucks. These are the 793s. We also have a smaller fleet of Komatsu 930s. So this is where I'm at today. So with these existing assets, again, from a bridging standpoint, I can look at biofuels, renewable diesel. With electric drive trucks, which are these Komatsu 930s, you can actually apply trolley assist technology, potentially 20-35% improvement, offsetting diesel. Starts to kick in. So it's really, what can we do now, right? So we're buying ourselves time. And at the same time, how do we prepare for the future? So I talked a little bit about autonomous, and that's really around the enabling technology that's required. And so right now, in this space, right, we're doing our first deployment of autonomous haulage, and I'll get into that in a second. But we actually feel that autonomous haulage will be an enabling technology for future battery electric trucks. But there's a lot of work going on over here, but this space over here is not ready. And so we got to give it time, and it's got to get refined, and it's got to be iterated. But again, technology, you got autonomous, you have battery management systems. This is an example of a static charging system. Rather than your traditional overhead trolley, there's companies that are working on a rail system. So those of you that have been to Europe, you'll see that third rail from the train systems that they have over there. It's been around for 50+ years. They're actually talking about putting a rail on the side of a haul truck and having an arm that goes out and grabs that rail. So I won't get into a lot of detail here, but if you take, the information on the last few slides, you kind of go in and you figure, okay, this pathway that we're on from where we're at today to the future, right? We've got our 2030 target. You have your 2050 net zero. What are some of the things we can do? Here's all the activities around the scope 1. So I talked about operational efficiency, alternatives to haulage, alternative fuels. Again, how do we prepare for the future? So we're working on autonomous haulage solutions. We actually have projects around static and dynamic charging. There's a lot of collaboration going on. I'll talk about that in a second with Cat and Komatsu specifically. Again, that's around how we prepare for the future. We actually have a separate power group within the company that's working on how do we take non-renewable electricity and convert it to renewable, right? So move away from gas, coal, over to wind, solar, nuclear. And then this scope 3 is actually under development as an industry. They haven't quite tackled that yet. So this is really where the priorities are. But this gives you an idea as a company, like for myself and for my team, these are the activities that we're involved in right now. Again, what can I do with existing assets and how can I prepare for the future, right? So focusing on the things you can do and the things you can control. So this, again, snapshot, some of the progress. This is a picture of the Caterpillar 793 battery electric haul truck. We actually, they unveiled this last November. In 2022, sorry. This is a 793 240 ton. And I'll have another slide on this one. So there is a battery electric truck that exists. Question is, can you make it feasible? Right? Can you make it viable? Komatsu, same thing. They actually have a prototype, Komatsu 83860. I don't know if those of you that are familiar, Anglo, South African mine, platinum mine. They actually developed a 930 truck retrofit with a hydrogen power module. Lever is actually working on both hydrogen as well as battery. And then there's actually a new player in the space, a company called First Mode. And First Mode actually partnered with Anglo to develop this hydrogen truck. And Anglo actually owns a majority stake in this First Mode. But they've actually pivoted as a company, and they actually have come up with a hybrid haul truck, hybrid power module. So you take an existing diesel engine, and then they have a battery. And so you run on diesel, and when you can, you're charging that battery and you're running on battery. And so there's a diesel offset with that. So like you guys all probably heard about, you know, Ford went all in on electric vehicles, GM went all in, and they did that a couple of years ago. And then here within the last 6 months, you hear them kind of pull back a little bit because the demand's not quite there. It's very complex, it's very capital intensive. And so they're saying, well, we're gonna actually pivot a little bit. We're gonna start doing hybrid vehicles. And that's actually something that Toyota's been doing for a while. So it's really kind of interesting that even just in the mining industry, you have this process playing out where everybody's trying to develop that next generation truck, and it's all the right reasons and it's part of that future. But this is gonna take time. But the fact that you have this pivot to where somebody's saying, well, how do I take an existing asset? I can take an existing diesel engine. How do I incorporate a battery? And so they've actually developed a hybrid hybrid haul truck solution. So if you haven't heard about them, just type in First Mode. You can go to their webpage and learn more about them. So part of it is take an existing truck today. You can convert it to an HEV, hybrid electric vehicle. That same vehicle, when it's time, you can convert it to 100% battery electric. And then in the future, if hydrogen ever becomes a viable solution, you'll actually be able to take that same truck and put a hydrogen power module in it. So I mentioned the Caterpillar haul truck. So Freeport is actually a part of this program with Caterpillar called Early Learner. And so when I mentioned here November 2022, they actually did a complete cycle with this truck. They ran a 1 kilometer at a 10% grade, 240 tons. Max speed was 60 kilometers per hour. So the technology's there, it exists. A lot of the work that we've been doing these last year, 18 months is actually how do I make that a viable solution? Like that's good for a demonstration. It shows that a battery can work, but I need that truck to work like it does today. I need it to be productive. I need it to be efficient. Not to mention cost effective. Okay, and then I threw in this one here. So you guys will learn more about this in another month or so from Randall. But we're doing our first Baghdad deployment. So we're actually going to take roughly 30 trucks. It's a $55 million project. We're going to convert them over to autonomous. And so it's actually to benefit today. We justified it based on today's economics. I mentioned earlier, right, you're constrained by the workforce. We have a hard time attracting operators and retaining operators. So if I'm trying to run a fleet of, 30 plus trucks, it doesn't do me good if I can't retain those operators. So we're actually at a point now where we're having to pursue autonomous because it's a part around stay in business and assurances for the future. And actually Baghdad is targeted for a major expansion. So how do you go from 30 trucks today that you have a hard time operating because you don't have operators to doubling that to 100 trucks? Where am I going to get the housing? Where am I going to find these people? How do I retain them? And so now you see where, okay, enabling technology has an opportunity here. And so that's based on today. But this is actually now going to become a blueprint because in the future, when we're running, let's say, a battery electric truck like this one here, in order to keep this truck moving 100% of the time, how big of a battery system do we put on that truck? And that battery is only going to last so long because I still got to carry 240 tons of material. And I'll just tell you guys, the batteries for these trucks are in the 15 to 20 ton range. So if I'm putting 15, 20 tons on that truck, ideally, I can't have 240 tons. Maybe it's going to have to drop to 225 or 220. Now, remember when I said you might have a fleet of 50 trucks and now I'm going to have to start running 60 trucks? Well, if I have a payload of 220 instead of 240, I'm less productive. Like I have to make it up. So you can see why everything is so complex. But so part of this is this whole dynamic energy transfer. So you'll be hearing more about that, right? Trolley assist has been around for a while, but how do I actually recharge that truck and propel it at the same time? And that's some of that other technology. So with that being said, that's all I got. So I apologize, we were late starting. And I don't know if anybody has any questions. Yeah.
Well, this is a complex problem, but who is actually putting money to develop this technology? Is that mining companies? You're relying on the vendors and OEMs? I mean, how is that dynamic working?
Yeah, I mean, that's a really good question. So what I would tell you without getting into specifics, we, being Freeport along with other mining companies, we're investing money. So if I just take this Caterpillar example with the early learner program, again, I can't get into details, but I will tell you, Caterpillar has come out and said, this is a part of our business model. This is the direction we want to go. And so they're investing money. As a customer in this development, we as Freeport, along with other, so you have BHP, Rio Tinto, Newmont, Tech Resources, they're also investing in Caterpillar. So there's a lot of money between the mining companies and Caterpillar going into funding all this in the development. Because when you think about it, it's not just like, you know, expensive batteries and all that, but Caterpillar has to retool their factories, right? And how do you make the transition from today's truck to the future truck? Do I take over existing factory floor? I mean, how do I do all this? And you think about handling batteries and other technologies, it's, well, do they invest in new factories? So it's very capital intensive. So I gave you an example, us working with Caterpillar, but it's no different with Komatsu. Fortescue Metals, it's pretty well known. They have a good partnership with Liebherr. And so they're doing a lot of work together. We've had meetings with Liebherr. So FMG as a company actually is very high on hydrogen. And they actually want to develop the hydrogen market. They feel that that's part of the future. So as a company, it's not just mining iron ore, other commodities. They're actually looking to develop hydrogen as a commodity and something as part of their business to be sold as well as to be consumed. So there is a lot of investment going on. And I'll just leave it at that, but it's been a shared partnership at this point. But yeah, is Caterpillar probably paying for more? No question. Right? But they also stand to gain the most when they have to sell us 500 trucks. So.
Yeah.
Yeah.
First of all, thanks for your position. That was right. Yeah, seminar series. We talk about the one difficult challenge that the mining industry is facing right now, which is decarbonization. What would you say is there any other difficult challenges that the mining industry will have?
Yeah, so what I would tell you, so we've done some preliminary modeling. I won't tell you which mine, but we have a mine site that currently uses 65 megawatts of power to operate. We've done some modeling to move them to 100 haul trucks. And just those 100 haul trucks under a battery electric model is 80 megawatts. So you're going to take an existing operation at 65 megawatts to run everything. And now you're going to eventually one day have 100 trucks, but those 100 trucks need 80. And so I'll just tell you the biggest concern that we have, and it's actually one that's shared with the other mining partners. We've actually talked about this, is there's actually not enough power being generated on the grid. So like Caterpillar will solve, Komatsu will solve, Liebherr, Hitachi will solve actually making all this work. But then it's going to be like, well, where's the power? Right? It's got to be renewable power, because when you think about the whole scope 1, scope 2 relationship, with scope 1, if I make this a zero emission truck, I'm basically moving that burden over to scope 2. So I'm putting all the pressure on the power people within our company, like, hey, I need renewable electricity, let's go, right? And so I'm giving you an idea. So even doubling that operation from 65, maybe they go to 130 megawatts. I need another 80 on top of that. So now you're talking over 200 megawatts, and that's one operation. And we got like 9 of them. So there's not enough power. So when people talk about like the role of nuclear power, right? It's really all the above, right? If you're gonna get there, you need it, you need wind, you need hydro, you need solar, nuclear. It's gonna take everybody pulling ropes in the same direction. Otherwise, we're not gonna get there. So, but I'll just tell you, that's actually the bigger problem that we have. So it actually, I guess for us, it's really just making sure we're doing our part to solve this part of the equation. But then it's, yeah, we need that. So I don't know if that helps, but yeah, okay.
Jason, great job. Excellent presentation. But your last comments were right on the mark. You know, you look at resolution, right? And because of refrigeration, wasted components, and obviously the process inside. You're looking at 250 megawatts, and it's not enough room on the grid. So then you have to figure out, you gotta generate power. How are you gonna do that? And I mean, calculations for, you know, the amount of land area for solar, you know, PVs, and then it becomes impractical. There's no pipelines for gas to get it there. And the likelihood of permitting a nuke is, you know, decades, right?
Yep.
So that's a long-term issue. If you look at electrification, right?
That's right. Yeah, it's huge. And like I mentioned earlier, even if you move away from, let's say battery electric, right? So let's say I want to get to a point where I'm not worried about how do I get power from Phoenix, Arizona to Morenci Mine, which is 4 hours east. You're thinking about, are the transmission lines capable of handling all that additional power? So you start now building a case for like, well, what about hydrogen? Right, but then now you're in another area where it's like, okay, where am I gonna get the hydrogen? Okay, you wanna use electrolysis? Okay, you need water. Well, how much water is needed to produce a kilogram of hydrogen? And in the Southwest, and we're in Chile and Peru, water is scarce there. You don't, I mean, this is very complex and very challenging. So I don't know where ultimately it would go, but I will just tell you, this is my personal opinion, not a Freeport opinion, but my personal opinion is, you know, a lot of these projections, goals that society has, you know, governments, they're probably gonna get extended quite a bit. So at the end of the day, okay, it's still the right thing to do. We'll do the very best we can. But when people talk about, yeah, we're gonna be 40% reduced by 2035 or, you know, 50% by 2040, I don't think that'll happen. And when I share that with you, I'll just tell you, we actually are part of a lot of consortiums with a lot of other mining majors, and that is actually the #1 problem that everybody has said, where is the power gonna come from? Where's the energy gonna come from? So we're hoping, we got people working with government, we're trying to educate, you know, the permitting process and help expedite, make it more efficient, but it's gonna take time.
Good.
Yes. So I don't know if everybody heard that, we sometimes hear about like green copper. Right, so we're actually starting to see that. People care very much about where did this material come from? In the case of copper, where did it come from? Was it done responsibly? I'll pick on cobalt as an example, right? A lot of cobalt comes from areas of the world where there's child labor, human rights related issues, and that's a challenge, right? So with copper, it's no different in terms of we want to pride ourselves on making sure that we're producing responsible copper. And so we do have customers out there that are starting to inquire more and more about, okay, I can buy my copper from a warehouse somewhere, but I specifically want to make sure that the copper that I'm buying is done responsibly. And so at some point, there might be a premium on the copper that we produce as a company because we've made all the necessary investments, changes, enhancements in our business to make sure that we're doing it responsibly. If you want to learn more about it, there's something called the copper mark. that's out there, maybe you've heard of it. But there's a list of 23 areas of the business. And Freeport was a part of that along with some other mining companies, but we actually, all of our operations are a part of the copper mark. Meaning that out of those 23 areas evaluated, we actually have met or exceeded each of those areas. And that's, you know, again, sustainability, environmental, human rights, the list goes on, but we're all certified in the copper mark. In the industry, there's more and more companies that are signing on to the copper mark. There's even one for moly. So, you know, we have our Henderson and Climax mines here in Colorado. There's actually a molybdenum mark, and they're a part of that as well. So I do think in the future, it will make a difference, right? If you're Tesla and you're looking to shore up inputs for your cars, because you see that as a potential risk, you know, they're going to be very focused probably on, okay, where's this copper coming from? And so we want to position ourselves for that. So I can't really comment above any of that, but I'll tell you that's kind of the direction things are going. Right? Because there's a way to do things and a way not to do things, right? There's a right way and there's a wrong way. So part of our cost profile is because we have made changes to where we do pay more to do it responsibly. And so for us, does it make sense that maybe there's a premium on the investments that we've made? Yeah, sure. You know, we'd like to see that, but. So. Any other questions?
Yeah, got a question on the board.
Okay, so do you include the GHG carbon footprint from your suppliers, from equipment manufacturers, from energy generators? So what I would tell you, I didn't talk much about scope 3. Scope 3 is under development, but that is more tied in with supply chain. So the reference to the suppliers, what they're doing in their supply chain is under scope 3, and that's coming soon. But when you think about as well as equipment manufacturers, that's part of the supply chain. But when you think about energy generators, that's getting back to scope 2.
Okay, I think
Right, so if you're Caterpillar Komatsu, they're paying attention to where they're getting their electricity to power their factories and their plants. They're actually paying attention where we sourcing our steel. Is it responsible steel? So a lot of that is happening. Hopefully I was able to answer your question.
so. There's a follow-up question there. Yes, I agree.
Okay, so why does a trolley assist and hybrid approach not yield better results? So if you just focus on trolley assist, to make a trolley assist 100%, that means that from the shovel all the way to your dumping point and back to the shovel, you need to have a trolley system that haul truck can connect to. So if you're able to actually have 100% source of electricity feeding into that electric drive system, then you would actually have those results. But the way mines are laid out, you can't feasibly put in a trolley assist system effectively and efficiently. Now, that's also part of why there's focus on a next generation trolley system. I talked about like that third rail system. We'll see where that goes, but that's one of the reasons why you don't have as good results. When you think about hybrid, I guess that's kind of tying back into trolley and diesel again, but at the end of the day, I still need that 40 megawatts of energy. So where do I get it from? So I'm going to need some from diesel. If it's not diesel, what's going to replace that? Is it electricity coming off the grid through the trolley system? If I'm using hydrogen, right, where do I get that hydrogen? But hydrogen is similar to like batteries. The amount of hydrogen that I need to run for 24 hours in a day, I need a really, really big tank to put on that truck. And so if I can't put a big tank on the truck, how many times do I have to refuel that hydrogen? Am I refueling instead of once a day with diesel? Am I doing it 3 times a day, 4 times a day, 5 times a day? So, you know, I'm not sure, Steve, if I answered your question or not, but happy to follow up further.
Jason, awesome. how long it takes. I mean, there's a company here in town that's building 4 cap hydrogen powered locomotives. And the amount of time it takes to refill the fuels.
That's right. Yeah, it's not, and trains are the same thing, for the most part, you want those things, operating. And they're out oftentimes in the middle of nowhere, right? So where do you put in refueling stations? So, yeah, no, that's a good point. I mean, it's certainly not just the mining industry that's challenged. Yeah, the most one, you consider the potential for it. Yeah, Priscilla. I would tell you that, to your question, that's an example of things that we're looking at outside the box. We have some folks that are working on that. I mean, everything from like in situ mining, which has been around for quite some time, but we're trying to figure out ways to limit our need to be moving material that's not ore. But yeah, but I'll tell you, we have people looking at that actually, but I can't comment much further on that.
So thank you very much. This is Priscilla, and you did a great job on the presentation. I think the whole idea of increasing the sorting and separation earlier in the process, so you're maybe losing some ore, but really reducing the cost of processing what you've got.
Yep.
Yeah, good job. Thank you.
Okay, thanks, Priscilla.
Okay, thank you.
Thanks again for the opportunity. I really do appreciate it. So good to be here. All right.
Very much.
Okay.
That's pretty.
Yeah. Thank you. Yeah.
You thought about setting up a hackathon type competition to look at these. Freeport has done this several times here. It's becoming very popular with a lot of companies who get all of these crazy out of the box ideas and give it to the engineers to design. It would be very helpful.
Okay.